What's up, everybody? It's Hutch here, and we're on Module 6-2, Adding Linear Expressions. So the first thing we need to talk about is what is a linear expression? So this is going to be something a little bit later. We have an equation, and you can picture a graph here, and we have different expressions that will create a line. Okay, and so when you have a linear expression, it means it's an expression that when you plug in the variables, the ordered pair for those variables will create points on this line. Okay, and that expression is going to be mx plus b. Okay, where this here and this here are numbers. So you have your coefficient. Okay. And we talked about in the last lesson where a coefficient is in front of the variable. Okay, and it says how many of that variable you have. And then this is just going to be a constant. Okay, and so when we're talking about this linear expression, okay, it has to fit this form. But understand that we could have 2x plus 0, which means really you could have just 2x and that would be a linear expression. Okay, but the only thing that you cannot have are other exponents, okay, other than 1, because really think about this too. Okay, x to the first is the same thing as just 2x, so that's okay. But we can't have x to the third. We can't have a division problem. It has to fit this. Where you see a number times x plus a number. Okay, so that's what I want you to be aware of. So let's go ahead and sort some linear expressions. Okay, so if we look at this, okay, well, that doesn't fit it because it has a squared. So this is non-linear. Okay, just like 5 times mn, that didn't fit this template of mx plus b. Okay, or a number times x plus another number. Okay, you can see we have a number to the fourth, so that's dead. Same thing as our negative 5x squared. Let's look at the next one now. Okay, so we have a number times x plus a number. So this would create a linear, this is a linear expression that would create a straight line on a graph. Okay, and it's okay to have a negative amount of x, but it has to fit that template. Okay, all right, do we have a number times x plus a number? Well, we do because of KFC, right? So we have 1/2 x plus a negative 5, but we can just write minus 5. Okay, that's the more proper way. All right, we have a division problem. That definitely doesn't fit a number times x, okay, plus a variable. And so when we're looking at something like that, okay, it doesn't work because remember, we could 6 divided by x is the same thing as multiplying by the reciprocal, but that would still be 1 over x. That doesn't fit the situation that we're looking for, that linear expression template. And then, of course, x cubed, we can't have any exponents greater than 1. Okay, so there's sorting linear versus non-linear. Okay, all right, let's go ahead and get into adding linear expressions. There's a couple ways you can do this. Some people like to stack them on top because really, look, you have this linear expression plus this one. But I want you to remember this. When we have addition all the way across, which we do because of KFC, okay, because of the commutative property, you can move those around any order. So really, we don't even need parentheses here at all. So what we're going to do is just look at it as a whole bunch of different terms. And remember, a term are all the numbers, okay, between the addition symbols. So we have 4 terms here, and adding means joining them together, right? So let's go ahead and do what we've done before, which is combining like terms. And so I have an x club, and I have a negative 7x. Make sure you include the positive or negative. And so we have a total of, different signs subtract, 7, 6, 5, 4, 3. We have a negative 3x. And then I have, let's look at our constants. I have a negative 2 and a negative 3. And so that adds up to be a 3, 4, 5, negative 5. Okay, and make sure you have that addition in between it. Remember, to simplify, you cannot have parentheses, so we're always going to go back to just representing that as a minus 5 instead of adding a negative 5. And so this ends up being my answer. Okay, so very similar to yesterday, really. All right, let's go ahead and add these. We have some fractions now. We see that it's all surrounded by addition, including the last one if we KFC it. So let's combine like terms. So I'm going to go through my highlight process and combine my X club. And then we have our constant club. Okay, so let's go ahead and add them together. Of course, adding thirds and twelfths, I have to have common denominators. So I'm going to change that real quick and multiply by 4 over 4. And so we end up with 4 twelfths. Okay, so let's go ahead and add 4 twelfths and 5 twelfths x. Puts us at 9 twelfths x plus 9 plus a negative 4, different sign subtract, is 5. Okay, and there we go. We have 9 twelfths x plus 5. I could simplify the 9 twelfths x as well if I want. Divide by 3 over 3, and we would get 3 fourths x plus 5. Okay, would be another appropriate answer. All right, so go ahead and pause and try the check. Okay, you can see again it's all surrounded by addition symbols. Okay, including that one. Okay, so we can use commutative property and add them up in any order. So I'm going to look at my X club. And then I'm going to look at my constant club and make sure I'm including those symbols. Okay, so we have a 1/4 x plus a 2/3 x. Let's turn these all into twelfths. So times 4 over 4. So we have 8 twelfths x, and times 3 over 3. We have a 3 twelfths x. So this is what we're combining for those. Puts us at 11 twelfths x. Now let's add our constant club. Negative 8 plus a positive 4 is a negative 4. We know that we can't leave it like that with that parenthesis in it, even if it is organizational. And so we have to officially simplify it by changing it back to the minus 4. Okay. All right, so there we go with that. Let's go ahead to your apply and check, and that's it for the notes. Okay, so we have the Drama Club is selling tickets for their latest production. They're also accepting additional cash donations. They plan to save 20% of the money of all ticket sales and donations for the spring trip. Okay, so they're going to save 20%, so we probably have to figure out what that is at the end. Ticket sales and donations from 2 performances are represented in the table, where T represents the cost of the ticket. If tickets cost $9, how much money will they have available for the spring trip? Okay, all right, so down here in our table, we have Friday night and Saturday night, so we need to find out the total amount of ticket sales and donations, okay, so that we can then find 20%. So we could you technically could plug $9 into this ahead of time and then add it. But the point of this is to go ahead and add those together as expressions and then plug in the 9 so that you're plugging in the 9 to a more simplified problem. Okay, so really this is just adding these together. Okay, and so you can even look at it like that instead of horizontally. And we're still going to combine like terms because it's surrounded by addition. That only works if it's addition, not multiplication or division. Okay, so we have a T club and a T club. Okay, and then we of course have a constant club and a constant club. So we can join those together. 92 plus 34. I don't want to make a mistake, so we'll just do this. So we have 126T plus 109 plus 13 is 122. So there's a simplified thing, and now I can just plug in the number 9 to find out if ticket sales cost $9, what's the total amount that they made the entire time. We're going to do our multiplication first according to order of operations. and then add the donations. And we have a total of $1,256 in ticket sales plus donations over the 2 nights. Now there's talking about saving 20% of the money of all ticket sales and donations. So we need to take 20% of that. Remember, of means multiply. So 20%, remember 20%, if we swoop, we have to use decimal form. So 0.20 times that, okay? And that'll tell us what 20% is. So let's do 2.20 times 1256. And 20% of that is $251, and it's not just a 2, it's money, 20 cents. Okay, so how much money will they have available for the spring trip? They will have $251.20 for the trip. And there we go. Okay, bravo. All right, here's one for you to try out. It's the same idea. Okay, we have a week 1 and week 2 of ticket and concession sales. After all of that, they plan on saving 30% of their money. And they also let you know what the ticket cost is. So go ahead and pause and try this one out, and then you can hit play and see if you followed the correct process. Okay, all right, so I'm adding up the 2 days. Okay, highlighting my like terms. This is a requirement of you. Okay, even if it's a simple one, do it anyway. It's all about the habit. Okay, all right, so we're adding up our T club, 75 plus 82, and we have 157T. And then we're adding up our constant, so 130 plus 115, and we have 245. So this is the simplified expression. Now we can go ahead and plug in the ticket cost. So 157 times 5 plus 245. So let's find how much they earned all together. We have to do our multiplication first because of order of operations, and then add the donations. Okay, and we have a total of $1,030, okay, in sales. Okay, and remember, they're going to take 30% of that. Okay, so times, or 30%, swoop, is 0.3, so 0.3, and that'll tell us how much they're saving. So times 0.3, and we have $309. Okay, so how much money will the football team have for their summer camp? They will have $309 for camp. Okay, and there you go. All right, let's head to the homework and check this out. So 6-2 practice homework. We're going to go through some of these together and then let you practice on your own so you get really comfortable with this. Okay, so the first thing you need to notice, remember, is all of these terms are surrounded by addition, including this because of KFC. This allows us to just combine like terms. Okay, there's no distributive we need to do or anything like that. Okay, so we're going to highlight our club members, so 8x and negative 6x, and then we have a positive 9 and a negative 2, and then we can go ahead and join them together. So positive 8 and negative 6x is 2x, and we have 9 and a negative 2, different signs subtract, and we end up with 7. There's our answer. Okay, let's go ahead and number 2. Okay, let's go down to number 4 actually. Okay, number 4, it's surrounded by addition because of KFC, so always change the subtraction to addition. Okay, and then we can go ahead and highlight like terms. So we have negative 3x and a 4x, and then we have our, we have our negative 9 and our positive 8. Okay, so let's go through. We have a 1x, or just x, because of the negative 3x and a positive 4x. And then a negative 9 and a positive 8 puts us at a -1, but instead of writing plus -1, remember we just need to write x minus 1, okay? Because this would have parentheses organizationally, and we can't have that when simplifying, okay? And after you add expressions, you have to simplify. All right, let's look at number 7. So we're dealing with the fraction ones again, okay? So combining like terms, okay? We have the 1/4 x with the 3/16 x. We also have a -3 and a +5. So notice for that one, I didn't switch it. If your brain sees it that way, you don't really need to change it. You just need to make sure you highlight that it is a negative number. Okay, so -3 and a +5. Let's go ahead and combine like terms. To add fractions, I'm going to have common denominators, remember, only for adding. So times 4/4 puts us at 4/16 x. Okay, do a rewrite there. And so 4/16 x plus 3/16 puts us at 7/16 x. Okay, just don't forget that x. And then plus, we have a +5 and a -3 constant. That puts us at 2, and you're done. Okay, all right. Let's go ahead and do, it looks like they're all good. Let's take a look at number 10 together. Combining like terms, they are all around addition. Okay, so I'm KFCing those. I have a -9x and a +2x. I have a -4/5 and a +2/3. All right, let's go ahead and join them together. Different sign subtract, 9, 8, 7. So I have a -7x, keep the sign of the bigger number. And then our next term combined, we have fifths and thirds. I can't add uncommon denominators, so I'm going to have to probably change both of these. Let's see, probably to 15ths here. So times 5/5, we'll multiply by each other, times 3/3. And we get -12/15, and we get 10/15. So now we can go ahead and join those together. Different sign subtract, and so we have -2/15. Remember, because of the adding a negative, you have to go back to just saying -2/15. Okay. And there's your final answer that is most simplified. Okay. All right. Let's go ahead and we'll do 2 more together on here just to make sure you're good. And we'll do 1 on the top here, number 2. Nice simple one. 5x and a -8x. We also have a +4, and if we KFC this, a -2. Okay, and go ahead and combine like terms. So we have a -8x and a 5x. Different sign subtract. So we have a -3x plus 4 minus 2 is 2. And there we go with number 2. Let's go ahead and do one fraction one. We'll do number 8 here. I'm going to KFC here real quick, and there we go. Let's highlight like terms, the X club, and we have the -3 and 1 constant club, and let's combine like terms. I can't add halves with 6, so I need to change this by multiplying by 3/3, and we get 3/6. So now I can go ahead and join those. Make sure you put the x there so you don't forget. 3/6x plus 1/6 is obviously 4/6x, which can be simplified. And then let's join the constants. -3 and a +1 is a -2. And I can do a lot of different simplifying here. Okay, so I can simplify the 4/6 by dividing by 2/2. And we get, let's see, what, 2/3 x, and then we just write -2 instead of plus the -2. And there's your final answer. So that's something we're going to be looking at too to make sure you are simplifying correctly. So the rest of that top will be yours. Let's take a look at number 13. It's the same idea. It shows the length and width of a rectangle. Write the simplified expression for the perimeter of the rectangle. So the only twist with this is we have the length and the width. So think about that. They're only giving you one side. Here's the length, and here's the width. And so we actually have double of those. Okay. So what's interesting with this is you could just add up a ton of those and do 3x plus 6 plus 3x plus 6 plus 2x minus 4 plus 2x minus 4. Or you could technically do distributing first. You have two of those, and you have two of those. Okay, so however you want to do it, I actually like the distributing because it's a little bit less work. If I take two of my lengths, you can see that I end up with 2 times 3x is 6x plus 2 times 6 is 12. And I'm adding that with the other one. So 2 times 2x is 4x. KFC that. 2 times a negative 4 is a negative 8. And now then you can go ahead and add them together, and that's going to get our grand total. So we have the 6x club, or we have the x club, and we have the constant club, and then you just join them together and we get our total perimeter. Okay, so 6x plus 4x is 10x. The positive 12 and negative 8 is positive 4. Okay, and there we go. This is actually the perimeter. So P equals 10x plus 4. Okay, all right. Continue the next page. The apply is just like the notes. So this will be for you to do. You can go back to the notes to review that if you need. All right, so there's your homework. Let me know if you have any questions. Okay, take your time, do everything that I taught.